This is the second lesson in using the slope formula to calculate the slope of a line. And in this case, we're just going to use the algebra and then verify our solution on a piece of graph paper. And so what we're going to do here is you're asked to find the slope of the line between 2 points. So we're given 5, -7 and -3, -9. And anytime you're given 2 points and asked to find the slope, use the slope formula, which is y2 minus y1 over x2 minus x1. So we write down our coordinates, and these are just from above. And so what I want you to notice now is that we've got to assign variables to these coordinates. And so we're going to let this be our second coordinate. So that means that y2 is -9, y1 then is -7. And since this is y2, then the -3 has to be our x2. And since this is y1, our x1 has to be 5. So we sub this into our equation. So we're going to sub in for y2 and y1. So it's minus a -9, take away, or minus -7. And -3, take away 5. And make sure you sub in correctly. So -9, take away -7 is just -2, and -3, take away 5 is -8. And so watch your signs when you're working with your integers here. And this simplifies. The negatives cancel out to become positive, and 2 over 8 reduces to 1/4. And so the slope of the line is 1 over 4 for the line between 5, -7 and -3, -9. So now we're going to quickly verify the solution here using a piece of graphing software. So we're going to plot the points 5, -7. So we go over to 5, down to -7, plot our point. And so there it is. And then -3 down to -9, plot that point. And now what we can do is draw a line between the 2 points. And the slope between these 2 points is we go up 2 and over 8. All right, so the slope is 2 over 8, rise of 2, run of 8. But then that reduces to 1 over 4, because going up 1 and over 4, if you do that twice, then you've gone up 2 and over 8. So 2 over 8 and 1 over 4 have the same slope because those are equivalent fractions. So let's take a look at another example. And here we're asked to find the slope between points 4, -3 and 2, -1. And so once again, start off with your slope formula and identify the coordinates that you're using. And so now what we're going to do, again, assign the variables to each coordinate. So y2 will be -1, y1 will be -3, x2 then is 2, and x1 is 4. So now we sub each of these into our formula for slope of a line, and we find that -3 take away -1 take away -3 over 2 take away 4. And notice that these are minus and negative, so you change that to plus positive. So this is -1 plus 3, which is +2, and 2 take away 4 is -2. And this simplifies to be -1, which is -1 over 1. And so now let's take a look at that on a graph. So if we quickly graph this, its first point is 4, -3, so we plot that point. The next point is 2, -1, so we plot that point. And then we can draw the line between these 2 points, a line segment between the 2 points, and we find that we go down 5 and to the right 5. So that's a rise of -5 and a run of 5. -5 over 5 reduces to -5 divided by 5 is -1. And we'll take a look at another question. And here we're asked to find the points, the slope of the line between the points 3, 6 and -3, 6. And so once again, start off with your equation for slope of a line given 2 points. And you sub in then for each of the variables. So y2 here is going to be 6. y1 also is going to be 6. x2 is -3. x1 is 3. And so now when we sub into our formula, we get 6 minus 6 over -3 take away 3. 6 minus 6 is 0. and negative 3 take away 3 is negative 6, but 0 divided by negative 6 is just 0. So this is a really important one to look at on a graph because we had a slope of 0 and we want to see what that looks like. So if we plot the points 3, 6, which is here, so over 3 and up 6, and negative 3, 6, we go to negative 3 on the x-axis and up to 6 on the y-axis. And if we draw our line, note that it is a horizontal line. And so what we then, remember the slope of the rise is 0 and the run is 6. So we're not going up or down here. So it's a horizontal line. And so the slope is 0. And so what you should note then, and this is always the case, the slope of a horizontal line is always 0. So we're going to take a look at a final example. And here we're asked to find the slope of the line between the points negative 4, 12 and negative 4, 5. And just as before, we're going to start off with our slope formula and identify our coordinates and then assign our various variables. So first one, y2 is going to be 5, y1 will be 12, x2 will be negative 4, and x1 will be also negative 4. And so now when we sub that into our formula, we get 5 minus 12 over negative 4, take away negative 4. Remember that negative 4 minus negative 4 is negative 4 plus 4. So this is the important one. We end up with negative 7, which is 5 minus 12, over 0. And anytime you have 0 as your denominator, that number is what we call undefined. And we're going to take a look at that on a graph. So on a graph, we're first going to plot the point negative 4, 12. So negative 4 and up to 12, and plot the point. And negative 4, 5, plot that point, draw the line between the two. And you'll note that here we have a rise of negative 7 and a run of 0 because we're not going left or right. There is no run. And so that means that, as we said before, the slope of the line is undefined because anytime you have 0 in the denominator, that slope is undefined. And since whenever you have a vertical line, there is no rise or there is no run. So the run is always going to be 0 because you're not going left or right. So a vertical line always has slope that is undefined.